Hello, thank you for watching this video. So in this video, we're doing question 9 of November 2024, question paper mathematics paper 1. And the topic is still calculus, but we're doing cubic functions as you can see over here. So question 9 did as follow. They are saying A and B are turning points of a graph of f below. C is the y-intercept. So you're told that A and B are the turning points of this function here, which is f. Let's just write f there. And then they're telling you that C is the y-intercept with coordinates 0 and 7. No problem. So, at 9.1, they're asking for which values of x is the function decreasing. So they're asking, where is your function decreasing here? What are the values of x? Fine. If you look at your function, when it appears here, you can see it's increasing. And then we have a turning point here. This is a turning point at this point, turning here. And then look here, it's going down, which is decreasing up until it turns here, and then it went up again. So, you can see, from negative infinity, this is positive infinity here, from negative infinity up until 1 here, because the x value is 1 here, up until 1, the function was increasing the whole time. So this function on this interval is going up the whole time. So it is increasing. So the positive indicate the gradient, right? Look at the gradient, it's negative because it's going down here, it's going down. And then this is a turning point, it's going up again. So you want where it is decreasing. It's decreasing here between this A and B. The x-coordinate of B is 5/2, right? So it's only decreasing on this interval here. So at the turning points, it's not decreasing, not increasing. Those are stationary points, right? It is stationary there. So it's not decreasing, not increasing, just turning there. So it's increasing between these points with the end points being excluded. So between this point and that point, all the x values that are in between, the function is going down there. So if you want to write those, say x is an element, round bracket, 1 to 5/2. I'm not using the block bracket because the points, the end points themselves are not part of that of that decreasing interval, because of the turning points, which is the end points, is stationary there. Or maybe you can say my x value is less than 5/2 and greater than 1. I think they would accept this as well. So that's how you do this. So it's increasing from negative infinity to 1, with both those being included together with 5/2 to positive. Sorry, both of those being excluded. Both negative infinity and positive infinity excluded. So on this interval, x an element of minus infinity to 1 is increasing. And on this interval, on the left hand side, because you can see it's going up there after this 5/2. So you can say x an element of 5/2 to positive infinity is also increasing there as well. So the endpoints are being excluded because negative infinity is not a real number, so you can't really include. What are you including if it's not a number? And the turning points, you're not including them because it's not decreasing, not increasing, it's a stationary point. So I'm done there. So what are they saying? They are saying write down the x-intercept of f prime, the derivative of f. So they want you to write the x-intercept. They want you to write the x-intercept of f prime, the derivative of f. Fine. So let's say you have your function. Let's suppose that f of x, which is this function of a, is called ax squared. Ax cubed plus bx squared plus cx plus d. Right? Fine. So they want the x-intercepts of what? Of f prime of x. So f prime of x is 3a x squared, right? Plus 2bx plus c. So they want the x-intercept of x. So if you want the x-intercept of this, what do you have to do? You have to equate your f prime of x to what? To 0. But what is this? This is the derivative. What does the derivative give you? It gives you a gradient at a point. That's what a f prime of x gives you. It gives you the gradient at a point. So if you're equating this to 0 to find its intercepts, It's more like you are finding the points where the gradient is equal to 0. And you know the gradient of a function is equal to 0 at the turning point. So you'll be finding the x values of the turning points, because at the turning points, the tangents that you can draw there are horizontal tangents, which is the tangents that have a gradient of 0. So if you want the x-intercept for f prime, which means you have equate f prime to 0, which means you're equating your gradient function to 0, which means you're looking for the points where the gradient is 0, and those points are the turning points, which is that point over there and that point over there. So it's x is equal to 1 and x equal to 5 over 2. That's where the gradient is. That is the point where your x-intercept, where the x-intercept of this is equal to 0. So those points are the turning points. Just one more time, I'm saying that your f prime of f gives you the gradient at a point. If you're saying you want the x-intercept of f prime of x, you have to equate your f prime of x to 0. But your f prime of f gives you the gradient at a point, and the gradient at a point is 0 at the turning points, which is that point A and that point B. So I'll say the x values where we find the x-intercept of f prime are x is equal to 1 or x is equal to 5 over 2. That's what I was saying. Because those 2 points are the points where the turning points are. And that points where the turning points are, that's where your f prime, which is your gradient function, is 0. And I'm done here. So I'm going to move to the next question, which is 9.3. What are they saying at 9.3? At 9.3, they're asking for which values of x is f concave up. They're asking the values of x for which the function f is concave up. So, what does it mean to be concave up? Which should it have a shape like this? Concave down, it have a shape like that. So this is concave up, this is concave down. So they want you to tell them the values of x where a function have a shape like this. Just look at the start of the function. You see a function, if you go all the way up to this turning point and go maybe up to some point somewhere here, you can see this part is concave down, this part, right? But after some point here, you can see it will be concave up. At some point somewhere in between A and B, its concavity changes. So it changes from being concave down to being concave up. And the point at which the concavity changes is called the point of inflection. And that point of inflection is the midpoint of your turning point. So the point of inflection with the midpoint will be sitting at the midpoint of the x coordinates of the turning point. So if you can find the midpoint of the x coordinates of those turning points, then you will find the point of inflection. This is where the concavity changes. At that point of inflection, it is not concave up, it is not concave down. The concavity is changing. The same way you're saying at the turning point, it's not increasing, it's not decreasing, it's changing direction. So we need to find that point, and we know after that point, it will be concave up. For all values that are on the right-hand side of that point of inflection, the function will be concave up. Because you can see from here all the way to some point in between A and B, it was concave down, because you can see here this shape. And then afterwards, it is concave up. So after that point of inflection where the concavity changes from being concave down to being concave up, the function of yours would be concave up after that point. So we need to find that point of inflection. So to find the x coordinate of the point of inflection, it's called the x coordinate of the turning point 1 plus x coordinate of the turning point 2 all over 2. So your x coordinate of the point of inflection will be called x coordinate of the turning point 1, which is 1, plus x coordinate of the turning point 2, which is 5 over 2, all divided by 2. Find an answer to this. An answer to that will be the point where the concavity changes, which means your concavity will have changed from being concave down to being concave up. You find that point. What is it? So you say 1 plus 5 over 2 all over 2. So the answer is 7 over 4. Right? That is 7 over 4. Which is equal to what? 1.75. Let's say this point here is 1.75. 1.75 over 4. 1.75 over 4 is equal to what? 1.75. 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 1.75 This is the point of inflection. This is where the concavity changes. So on the right hand side, for all values that are above this thing will be concave up. This is not included because that is the point of inflection. The concavity changes there. So for all x values that are greater than 7/4, this thing will be concave up. Or if you want, you can say for x values from where? From 7/4 to positive infinity. We're done here. So we'll go to 9.4. What are they saying at 9.4? They are saying determine the values of k for which y defined by f of x plus k will have 3 positive x-intercepts. So they've given you that y is called your f of x plus k. What is f of x? F of x is what is your equation for this thing over here. And what is k? K is a constant, right? What does this constant do? What does adding a constant here does? This is a vertical shift. So it's either shifting this up or shifting down. That's what you're doing. So it is a shift. So they're asking, how should you shift this function over here so that it has what? It has 3 positive roots. Or 3 positive x-intercepts, which are positive roots. Because that's saying, determine the values of k for which y, which is defined by this, will have 3 positive x-intercepts. So you want this to have 3 positive roots, 3 positive x-intercepts. So if you want x-intercept, you allow your y to be 0, which means what you have 0 is equal to f of x plus k, right? So the question is, how should you shift this function so that you have 3 positive x-intercepts? That's what they're asking you. No problem. So how do we go about this? There are many ways you can look at it. You can look at it from the graph perspective, right? Or you can just work with it from here. I will try to do both, but let's try to work it from here. Let's transpose the k to the other side. You'll have f of x is equal to negative k. If you think about k is a constant. K is a real number. It's a number because they're asking you how many units should you shift this thing. So we know k is a number. So to some degree, what you should look for in this case, look for the point of intersection of your function f and some constant, right? Or maybe some line, so that these two, they intersect and have 3 positive roots. For example, this is your graph there, and this is a straight line. So you want to have your horizontal, and this straight line is horizontal because you can think of it as g of x is equal to negative k. Your k can be g of x is equal to maybe 6, or maybe minus into minus 6 maybe, which is your 6, right? So this is just a line that is horizontal. So what I'm trying to say is, just think of your k as a function on its own that is g of x equal to minus k. So, and you know this g of yours is a function that is horizontal, because this is a horizontal straight line if you think about it. So you want this straight line of yours to intersect your graph and have 3 positive roots. How will you find that? Let's say I draw a straight line here. You can see there's one root. Draw a straight line here, there's still one root. If you draw a straight line here, there's still one root as well. If you draw a straight line here, there's one root. If you draw a straight line here, you can see there's one root. If you draw a straight line through the y-intercept, you can see still there's one root over here. But look now, if you draw a straight line on at 8, at y is equal to 8, which is a straight line like this, at y is equal to 8, you have 3 roots but only two of them are different. So we have this root over here and two equal roots that are sitting over there. Right? No problem. But look now, if you draw above this line, you have three positive roots. If you draw at y is equal to 9, because this is y is equal to 9 here. And this is, let me say y, let me say this is my g of x is equal to 9. Are you with me? Or maybe, let me say negative k. What should I say? Say g of x is equal to 9. This is my straight line at y is equal to 9, which is the horizontal line passing the 9. So we have 2 here and 2 there as well. And when you had g of x equal to 8, you had 2 that are distinct. You had 2 distinct roots. But for values that are between, for the values of g that are between the 8 and the 9, which is those values that are between 8 and 9, you can see you have 1, 2, 3. So you will have 3 positive distinct roots. So for the values of g that are between 9, that are between 8, right? Because this is 8 and 9. You will have 3, you intersect your graph 3 times. You can see, it doesn't matter where I draw a horizontal line. If it's between 8 and 9, I'll intersect it 3 times. And I will have 3 positive roots there. So in that case, I can say, okay, this, I want these two to intersect and have what? 3 positive roots. This will happen if my k, negative k, is above what? Is above 8, but my negative k is up below 9. So divide by negative 1, divide by minus 1, divide by minus 1. So we'll have minus 8, k, negative 9. Therefore, my k values should be above minus 9, which is but below minus 8. So if you look at this in terms of shifting the graph, look what happens. If you shift your graph, let's say now you are adding the negative k. If you shift your graph 8 units down, this point here will sit over here, right? If you shift 8 units down, this point at B will sit here. And this one will be above. So you will have a similar graph, right? But it will be like something along these lines. Will it really look like this? No, it will not look like this. I said B will sit there, so it will be something like this. It will be something similar to this. But look now, if it's sitting here, you have 2 distinct x-intercepts, right? But then now, if you want to have 3 positive x-intercepts, it must go down more than 8 units, right? It should go down more than 8 units, but not more than 9 units, because if it goes down more than 8 units, this will be below here. And then now your graph will look something like this. Let's say it's here, and the other point may be somewhere there. So your graph will look something like this. So you can see that if you shift more than 8 units, you will have your 3 positive roots, right? But at the same time, you should not pull it down more than 9 units. Because if you pull it down more than 9 units, if you pull it 9 units or more, now this point, turning point of yours, will sit here or be below, but you don't want that. You want to have 3 distinct roots. So this is what we're talking about over there. And I hope it does make sense to you, as it does to me. It would be nice if maybe I was using a screen, because I was going to move it so that everyone can see it, but this is the most easier way when you're using a board like me. And we're done. Thank you for watching. Cheers.